Everybody have a good first day, the conference? Yeah, this is an excellent conference. It's my favorite conference of the year. Of the 13 integrates that I think I've been at 12 of them. I've only missed one, and this is the 9th year that they've asked me to speak, so I feel really glad to be here. And I want to especially thank everybody for being here at 8:30 in the morning on the second day. I know there's probably a lot of partying and everything last night. It might have taken a bit of effort, so thank you. Thank you so much for coming in. I've got two apologies to make. The first apology is to the people on this side of the room. It seems best for us to stay here, so if you feel a little less engaged by me talking, please come over and take some empty seats. And the second apology is that apparently at 8:45, in a few minutes, there's going to be a fire alarm that goes off as a drill, so we're going to have a brief interruption, but hopefully very brief. As for who I am, I'm a senior manager at Deloitte. I work in Australia, and most of my roles are integration architecture right now. That's kind of what I do. I do have a bit of a development background. And there's a lot of boring information on that slide, so I'm not going to cover it, because if you want to find out more, you can go to that QR code and find my LinkedIn profile. And by all means, if you want to connect with me, please do so. Just put integrate in the note to me so that so I know where you're coming from. I'll talk instead to the picture. So this picture represents two of my greatest passions in my life, which is, it's a picture of me just about to play piano at the Easter Vigil service at my church. So those two passions are music and practicing my Catholic faith. And it's a good combination, because not only do I get to give some of praise back to God with the little bit of talent He gave me, but also playing in the church is a good place because the people are kind and patient enough to put up with my amateur skills on piano. So there we go. So if you subscribe to Gartner or any of their things, then maybe about 5 years ago you might have seen this article called Turbocharge Your APIs Platform with a Digital Integration Hub. So this was Gartner's introduction of the concept of a digital integration hub. It came, I think we just lost someone. It came about 5 years ago, so it's not really new. It's why you notice I've changed my title a little bit from maximizing your APIs to actually modernizing the digital integration hub. We're going to look at it with a slightly fresh view, because things have kind of evolved a little bit in the data platforms area. So to do that, I'm going to talk about the three main components that make up the digital integration hub. We'll talk about APIs, we'll talk about data, and about integration. Now, I'm not going to spend a lot of time on APIs or on integration, because you guys are all experts on that. That's why you're here. But I will talk a little bit about the data platform concepts, because if you're like me, and that may not be your area of specialty, and there's some background information I think you need to know to understand where the digital integration hub comes from and how it works. So I'll talk about that. And then I will describe the digital integration hub. So if you don't know what it means, you'll learn from this, and also talk about how you would build that today in the Microsoft space. And then finally, I'll wrap up with just a couple of case studies from Deloitte, where we had a couple of real-world implementations of this. Now, this is a theoretical presentation only. There are no demos. So if you're here for the excitement of potentially seeing a demo fail, sorry, you'll be disappointed. You might have to go next door. Although I should tell you that I've been to a lot of Wagner's presentations, and his demos never fail. So you're disappointed there as well. I also want to shout out a couple of my colleagues at Deloitte. So we have some very smart people that work there. And one of the great things about working in a company with broad areas of expertise is that you benefit from everybody's collective knowledge. So I want to thank Alec, Gavin, and Michelle, who kind of helped contribute a bit to this presentation and also validated that what I'm telling you is factual. So, okay, let's start with APIs. So you guys know how important APIs are. They make the digital world go round. So this quote from Gartner, which was made many, many years ago, is still just as valid. today, but I'd like to think that if Gartner were saying this today, they would add 2 words to that quote, and that is digital and AI, because AI would not work today without APIs to have that happen. And why is it? What are so good about APIs? Well, just reviewing it very briefly, they enabled integration for us. They simplify integration a huge amount, because by having to consume APIs, which are contract-based, you don't have to get embroiled in all the specific proprietary formats and protocols and everything that you might have to talk to the back-end systems. By the nature of the fact that they're modular and you build APIs, then it improves scalability, because you can enhance and improve some services without necessarily affecting the other. And that modularity also helps developers, because you can develop components and then reuse them as you're going, rather than reinventing the wheel all the time. It adds a layer of security on top of your systems as well, because you can build that security into the API, and you can control who has access to the data and what data they can actually access. And it also increases flexibility, because you can create an API for a system and then have it used in multiple channels, whether that be mobile, whether it be computer-based or web-based or an integration system. You can reuse that capability again and again. And then one of the most interesting aspects too is the support for innovation, because by breaking down things into APIs, you can combine them and create new applications all the time that give you features that you wouldn't have in any particular system or application. So that's about all I'm going to say about APIs, because as I said, you're probably all very well familiar with that, being into the integration space. So I'll move on now to data. And data, I love this quote. It's an old quote, but it's so true. Data is, I think no one can argue that data is probably the single most valuable asset that any organization has. I mean, as human beings, we might like to believe that employees are the most valuable asset, but I think we know that that's not always true. We are a bit expendable, especially now in the AI age, where we're probably going to have a lot of our jobs replaced. But if you compromise the data of an organization, you can effectively cripple that organization. So it's important not only to keep it protected, but also to recognize what a valuable asset it is, and to develop a really good strategy for how you can use that and get the most of that data. And sadly, a lot of organizations don't really do that to the full extent and realize how they can leverage that data. So Gartner made this quote back in 2020. And my question to you is, how many of you think that this turned out to be true? That by 2021, enterprises would support more than 30% who are using data hubs would have 30% more use cases. Show of hands? 21, very few. Okay. Well, according to ChatGPT, apparently the answer is yes. It did come true. But ChatGPT was also keen to point out that data platforms have evolved over that time, and things have changed. And that's kind of why we're having a fresh look now at the Digital Integration Hub and see how that might be impacted by the changes that we have and the kind of new technology and platforms that we have. So I'm going to concentrate now on talking about 3 different data platform architectures or constructs, as whatever you might call them. I know that there are more than this, but these are the 3 main ones that existed at the time the original article was released by Gartner. And I think that it's important to understand the concepts of these so you understand why the Digital Integration Hub works and what it is. Now, 2 of them are very similar, and 1 of them is a bit different. So we'll start with the different one, which is the Data Hub. So the Data Hub, while the other 2 are more about, they're repositories of data and about long-term storage of data, that's not the Data Hub's primary functionality. A Data Hub is really meant about the movement of the data and to circulate. So if data is the lifeblood, then the Data Hub is kind of the heart, right? That keeps things keep things moving. So its primary responsibility are the management of that data, about connecting the producers and the consumers, and providing the governance and security and whatnot over that. Now, if that sounds a bit like integration, it's because it is, to a degree. There's definitely an integration component to it, and it would be part of most integration solutions. But it's not the whole integration story, and we'll get to that a little bit later. The other two constructs, the data warehouse and the data lake, are about long-term repository and storage of data, and also the processing of that data. But they do it in a different way. So data warehouse is very much focused on very, very well-structured data. So we would call this like a schema-first type of where to get the data in, it has to be in a certain format, right? And that's good because it enables use cases like business intelligence. It has very, very fast query responses because when you're looking for the data, it's already constructed in a way that makes it easy to find and to digest. So it has very consistent semantics for that, and it's very performant. The data lake is different in that it's really good at consuming raw, undefined data, right? So semi-structured and unstructured data. The emphasis on this one is about getting the data in and then doing whatever processing you need. So it would be like schema last. When you're pulling the data out is when you then want to format it and manage it and transform it. So whereas data warehouse is considered ETL, which is extract, transform, and load, then the data lakes are more like extract, load, and transfer and transform, because the emphasis on load first. And this is really good when you're needing to prepare and assimilate your data for analysis purposes, and when you have to, where it's more about getting the quantity of data in a variety of different formats. And it's great for feeding data science activities. Like if you're doing training machine learning models, you often just need a lot of data from diverse locations in order to gain the insights that you need. So the different purposes for those two things. So if you're an organization and you're deciding what management strategy that you want for your data, then which one do you choose? Well, the obvious question is, what are your use cases and what are you filling? But really the best answer for all of this is you need it all, because every large organization is going to have, use cases that fit all of those platforms. So this is where a more modern structure comes in, and that's called a data lakehouse. So if you can't guess by the name, a lakehouse is a hybrid structure which combines the best of both worlds of the data lakes and the data warehouse. And what that gives you is that you can assimilate all different kinds of data, so it would be structured, semi-structured, or unstructured, but you still have relatively fast query response and the ability to process that data well and balance sort of the storage and complexity and the cost.
Attention, please.
There's our fire alarm.
The fire alarm is about to be tested. The fire alarm is about to be tested. Please contact building administration if you have any.
Is that it? Okay. Yeah, I guess I'll continue then. So the data lakehouse, examples of that. There it is.
Attention, please. Attention, please. We are investigating an alarm condition. It may be necessary to evacuate the building.
Let's hope not.
Attention, please. Attention, please. We are investigating an alarm condition. It may be necessary to evacuate the building.
Okay, we'll keep going. Some examples of data lakehouses today are Databricks, Snowflake, and Apache Hudi. So I'm not going to go into detail about how they work because it would be beyond the scope of this investigation, of this presentation. But just to kind of point out that the idea of a data lakehouse is that it'll support both your...
Attention, please. Attention, please. The fire alarm test is now complete.
Yay.
Please respond to all future fire alarms.
Thank you. It's designed to support both operational and analytical data sharing. And you can kind of see how that works. You've got a data hub that's in charge of everything, the flow of the data, but you've got also a data lake, which you can just get all the data into, and then you can start processing that data into formats the way a data warehouse would be able to manage that data and make it accessible. So the one thing I am going to mention about data lake houses is that they're built on the medallion lake architecture. And if you were at Martin's presentation yesterday morning, then you would have been here to see him talk a little bit about that. So what you have with the medallion lake architecture is you have three sort of stages or three tier levels of data. And I'll just blow this up so you can see it a bit better. You have bronze, silver, and gold. So the bronze is really more all about ingestion of data, right? To get it into the system as rapidly as possible, which means you do the absolute minimal amount of validation on it. So you're encouraged, for example, to use very, very generic types like strings, binaries, variants, right? And not so much validation on that. So you get all the data into your storage, into your system. And then for the silver layer, that's where you start doing your cleanup and your validation of that data. You start to eliminate things like null records or null values and start maybe putting better, more stringent types on their actual data fields. And you can also, at that stage, start modeling your data as well and doing aggregations and stuff that are going to serve your APIs. So in this example, you have your customers and you have your transactions now being combined to a customer's transaction view, which would likely support some of the APIs that which you would need to consume it. And the same thing with the accounts and the opportunities. And then last, you have the gold layer. And in the gold layer, you really do even more processing on that to actually support all your analytical type of queries. So these would be kind of supporting say your Power BI dashboards and the queries that your executives would want. So it's in stages that it improves the quality and actually transforms it and modifies the way that it needs to be consumed. Okay, so now that's all I'm going to cover on the data aspects of it. So now we get to the fun bit, the integration. I don't know about you, but whenever I have to explain integration to people who are not integration experts, I love using the plumbing analogy. It just fits so well. Plumbing is about having fluids flow through your system, so integration is about data flowing through your system. If data is the lifeblood, then the integration is like your circulatory system, isn't it? And also, like plumbing, integration is always hidden in the walls. You don't see it, you're not aware of it until it breaks. And then you're very aware of it, very aware of it. So before we talked about the data hub, and we mentioned how it looks a lot like integration, and you're right, it does. But it's not the full story because an integration hub would encapsulate a data hub, but add a lot more functionality as well. So there are more responsibilities. For example, just like a data hub would handle real-time command and queries and also batch movement of data, integration hubs also need to handle events and publish and subscribe those events. There needs to be some API management involved and message transformation and orchestration. These are all the capabilities of an integration platform. So you guys know how important integration is, but I'm including this quote by Gartner because it emphasizes the marriage between data strategies and integration. So how important it is that integration is there to support that, and it works both ways. The data needs integration to work, but the integration also needs the data to work. So in just the conversation I had yesterday with Kevin, we were talking about what is the point of integration, what is it you're trying to achieve, and it's to serve your applications. So the integration is that link between the data and the applications that you need. And in addition to garters, I'll throw in a quote from someone from my own team. This is from Alec, who observed in a blog post that the integration teams and the data teams tend to be working more closely together. And that is so true. I can see that at Deloitte, that most of the big projects that we get on now that involve any aspect of data or integration is both of our teams are coming and working collaboratively together on that. So bringing it all together, we've talked about APIs, we've talked about data, we've talked about integration, and we see that the integration is kind of the glue that marries the data to the applications, and it does it in a somewhat decoupled way. And I've specifically drawn it this way with the 3 sprockets, because even though the API's sprocket isn't touching the data one, you know that if you move any one of these sprockets, it's going to move all of them. So there is a bit of a coupling still with the APIs and the data if all the integration platform is doing is linking your APIs to the data sources, right? There is still that sense of coupling, because if the data is not available in the back-end system, then the APIs aren't being served. And also, the APIs, the very act of querying that data, does have an impact on the system that it's querying the data from, right? Let me explain that a bit better with this slide. In Gartner's article, when they published it, this is the first diagram they showed, which is kind of the before picture. Show of hands, how many people at their organization would have an architecture that looks like this? Okay, good, yeah, right? It's not bad, by the way. It's not bad because it may serve very well. But there are some potential problems with it. And what I wanted to point out in this is that Gartner calls the integration layer a request-based integration layer. And that's because in this architecture, the primary responsibility of the integration layer is to field requests from the APIs down to retrieve or manipulate the data in the systems of record, right? And if you notice, and this is why I've included the original diagram, ugly as it is, if you notice that the services behind the APIs are called macro services, not microservices. And the point of that is because that's where all the work is done in terms of aggregating data and manipulating data when it has to be drawn from multiple systems. So those services can be kind of heavyweight, and there's a cost involved in that because, one, if anything changes in the back-end systems, then you've got to change all those services the way you're assimilating the data. But also, it can affect the response times of the APIs too, because those services have to do a lot of work to respond to it. So how do we fix that? So this is where the Digital Integration Hub comes in. Now, I've tried to get across in this diagram, probably badly, that what the Digital Integration Hub does is help to decouple the APIs a little bit more from the back-end systems. You all know how a transmission works, right? Sometimes the engine is not spinning at the speed that you need the car to go, so you have a series of gears and you kind of change the ratios of them to adapt that speed. So that's kind of what I was trying to get across here, that's what that does. And Gartner's description of what a digital integration hub is, he emphasizes low latency and high performance. So the primary objective of this is to speed up the performance of your APIs, right? While at the same time protecting the back-end systems. Because a lot of times the queries that the APIs are doing are of much lower value to the business than what the primary function of those systems of record really are. So it's, you don't want to detract from that too much, especially if they're high volume. So how does this look in the architecture? Well, we started with this one. This was the original. When you add apply the Digital Integration Hub, then what you see is that immediately you have a new layer in here called the High Performance Data Store. And that really is at the heart of what the Digital Integration Hub is. So let's look at it a bit more in detail. So what this store does is it's responsible for doing all the aggregation, the consolidation, the transformation, and the manipulation of that data from all those systems of record and assimilate it in one place, in one store. and make sure that it's highly available, highly queryable, very, very responsive. You would need a good metadata management system over it so that you can find the data that you want and categorize it to make it consumable. And it would be made up of things like a data warehouse or a data lake or a data lakehouse, ideally. Maybe an MDM if you need that for your system. And then there's analytics as well. Now, analytics isn't technically part of the high-performance data store, but it is often a driver for it, and it benefits highly from being able to get that information from the data store, because now, in this architecture, you're not hitting the back-end systems all the time when you're trying to do these expensive queries and processing. So that's the high-performance data store. Now, in the integration layer, you'll notice now that it's changed from request-based integration layer to event-based integration layer. And that's because the primary responsibility of this integration layer has changed, not from servicing the request from the APIs, but about shifting the data from the back-end systems into the high-performance data store, keeping that synchronized and keeping that data fresh. So that works a lot better. And then at the API level, there's very little change here. You still have your APIs and your API gateway, but now the macro services have turned into microservices or mini services, or we would probably say nano services. And the reason for that is because all the heavy lifting of doing the manipulation and the aggregation of that data is now done in a high-performance data store. The microservices really only have to serve it up. So that means that they're less expensive to maintain. They're also faster. So this is how you improve the performance of your APIs, which is the primary objective of a digital integration hub. I thought it would be worth clarifying. You've probably heard the term data integration hub and digital integration hub. And if you're like me, you probably thought that those terms were interchangeable. Not exactly. Really, a digital integration hub is really more of a specific type of a data integration hub, because its concern is basically about rapid real-time access to the data and supporting your transactional and operational systems. Whereas the data integration hub can do that, but it's also got a lot more responsibilities as well. So it's just, sort of a broader spectrum. So what are the benefits of a digital integration hub? So the primary objective, as we mentioned, was to speed up your APIs. So this makes your APIs a little bit more responsive while keeping your back-end systems from being overrun by those requests. And because you have that decoupling, that means that your APIs are available conceivably 24/7. So even if you're doing maintenance or upgrades or replacements of your back-end systems, your APIs can still serve that data from the high-performance data store. And of course, you get the benefit of using all your AI and your real-time analytics, because you can point that at the high-performance store, which is designed to serve all of that, and without, again, affecting your back-end systems. But it does come at a cost. There are some challenges. Creating a high-performance data store is a complex thing, so it can be a bit difficult to manage that. The canonical data model, which is really, I think, essential for being able to make a more generic and less proprietary format of your data for consumption, that is a big challenge. I've seen even very mature organizations struggle with that a lot, because you get so embedded in the sort of the proprietary format of your systems of record. You're just used to using it that way, rather than really making it more model what the actual business is and the business entities are. And then, as you know, with integration, supporting bidirectional event-driven integration is a complex thing. It's one of the challenges that we have. Publish and subscribe is such a great model to use. It's so extensible and expandable, but how do you track easily what the impacts are of changing something in the publisher? It can be very challenging. Also, it's important that when you collect that data, that you're able to discover it and actually use it. So you need really good metadata management and search capability across that, and that's not trivial to do. And some organizations just don't have the in-house skills to build this, so you've got to figure out how are you going to manage that. So let's look at what we can do to address it. So for the first one, the complexity of rolling out is, first of all, decide, do you really need a digital integration hub? Does your business require that? And it may be that it doesn't. So as we mentioned at that first diagram that we showed, some organizations that might suit. If your systems of record are simple, if the demand is not that great for APIs, you may be able to service it just fine without that added complexity. So it's, what's your return on investment going to be? The canonical data model really comes down, it's a lot of work, but it comes down to really understanding not only what your actual business data is, but also what your user requirements are. How is that data going to be used, and how is it going to best serve your analytical and your AI objectives? Of course, to build the integration, you really need to understand the integration patterns and think about what kind of patterns do you need to serve. Is it batch-based? Is it real-time based? Is it event-based? There are many different ways to approach that, and it'll depend on what your use cases are. For the metadata, you also need to think about when you're identifying what your business data looks like, is also how you're going to consume it and how you want to tag it so that it's labeled in a way that's going to be discoverable, and you're going to be able to create the joins that you need. And also you think about a good metadata management system and a good search system. There's a few different options out there and products. And then finally, how are you going to deliver this? If you don't have the in-house skills, you might have to think about engaging a partner. For a company, for example, that has the breadth and depth of experience in delivering things like a digital integration hub, like Deloitte, for example, might be the answer there to help get you started with that. Okay, so for that first half of this presentation, we've talked about a lot of general concepts. Now let's bring it to Microsoft and see how we can do this in the Microsoft landscape. So if we look at the different levels of the architecture of a digital integration hub, we can start to think about what kind of services do we have if you're going to build this in Azure, for example. The first one is the API gateway, and that's pretty easy. There's really only one choice for that, and that's API management. And I don't need to talk, I'm sure, to you about all the benefits of that, the good things that an API gateway brings you. In API management, you have the governance, the discoverability, the management, the obfuscation, all those things for managing an API. So that's a no-brainer, that one. When it comes to building the microservices, you've actually got a lot of choices. So you've got web apps that you can build. You build that on app service plans, and you can build web apps, mobile apps, and API apps. You've also got functions, and you can do either standard or durable functions based on whether or not you need to manage state for that. And of course, we have logic apps and the benefit of all of those connectors that come with it so that you don't have to write code to consume the APIs. And if you like working with containers, there are multiple options there as well. You've got container apps, which are scalable and give you sidecar functionality with Dapper. Or if you really need the full-blown complexity and scalability and orchestration capabilities of a Kubernetes cluster, then you've got AKS as well. And although it may not be quite so fashionable these days, I kind of have to mention Service Fabric because it was, after all, a platform designed to build microservices and does that very efficiently. And there may be more choices too. These are just the ones that I could fit on the slide and think about. If we move to the high-performance data store, so when you talk about storage of data, we've got multiple options in Azure for that. For relational databases, you've got SQLDB. For NoSQL, you've got Cosmos DB. And you've got PostgreSQL and Marion database and a bunch of other databases as well that we can store data in. But this being kind of an enterprise system, and when you're building something as sophisticated, you probably want something more along the lines of a data warehouse or a data lake. And Azure has both of those services as well. And then for management, so for governance and also for cataloging of that data, we have Purview to use for that. And for search capability, you've got Azure AI Search, which is very powerful in terms of how it can connect and build search, including vector databases, which are really useful in AI, especially if you're building a RAG pattern. Then when it comes to analytics, you've got Synapse Analytics, which also, by the way, is a data warehouse. So that could be a potential data warehouse for you if you want to use it. You've got Databricks with its analysis, which is also a lakehouse. So you have that capability. Data Explorer for doing analytics. And if you're wanting predictive analytics and you're training machine learning models, we have Azure Machine Learning as well. And again, there would be more services as well that you could use on top of that. And then finally, the integration layer is all the products that we know and love so much. So event-based integration, you've got Event Grid and Event Hubs. You've got Service Bus for a very, very robust messaging capability. And if your data is streaming data and you need to be able to do that in real time, you've got Stream Analytics to help with the ingestion of your data. You've got logic apps and functions, which can do simple things like maybe transforming your data or even orchestrating certain processes and connections. And for ETL, for bulk data movement, you've got Data Factory with its pipelines and all of its connectors. So really what you got with Azure is just this great big toolbox of all these different services that you can use to build any architecture that you really need, including a digital integration hub. But the thing is, with all that choice and all those different tools, you kind of have to know how to wield them, right? If you're setting out to build a shed and you decide you're going to buy all the best tools on the market, the professional craftsman tools and everything, the highest quality, but you don't know how to use them, your shed's probably not going to come out very well, right? So that's something you need to think about. So where do you get guidance on all of this? Now I looked around to see if I could find a landing zone for a digital integration hub, to get some advice from Microsoft. I couldn't really find a landing zone. But what I did find was something called the Azure Digital Integration Hub Accelerator, which is basically a collection of templates that you can use to help provision, do the basic engineering and provision the platform. Now I have to warn you, it looks like that this hasn't been touched in 4 years. So it doesn't necessarily use all the latest stuff. But if you do want to have a look at it to get started, it includes, it will provision for you an API gateway with some function apps. For the high-performance data store, it provisions a PostgreSQL database as well. And for integration and filling that, you have the event-based management with event grid topics and then connections to logic apps as well. That's what it actually provisions for you, and there's a sample application involved. On top of that, you can then add, if you want an Azure Synapse for your analytics, if you want to use that, or any of the other analytic platforms. It's kind of up to you. Now you have more choices, right, than you did back when I think this was created. And then all the other goodness in Azure that you would use with Azure Monitoring, Policy, Active Directory, and all those, which is now called Entra. And all of this is built on provisioned on an Azure Arc-enabled Kubernetes cluster. So that's something you might consider if you want to get started with it, but there's many different approaches. It's still a lot to manage and a lot to think about when you're building your own. So another option, which you would all be aware of by now, after some of the presentations you saw yesterday, is Microsoft Fabric. So Microsoft Fabric is a SaaS solution where it's all provided for you, right? It's basically an all-in-one, end-to-end data management and analytics platform for you. So it includes end-to-end integrated analytics. It's underpinned by data lake storage called OneLake. It's kind of designed in a more user-friendly way. I kind of think of this as what Power Platform is to Azure PaaS integration, right? Where it's just provided, it's a little bit more friendly for users to use, and it's got AI woven all through it, as well as the governance capability. I keep losing the monitor for some reason. It keeps turning off, flickering on and off. Okay, so there's a lot of different components that make up. You have Data Factory built in for your ingestion of data through pipelines. You've got data engineering for processing the data, data science for supporting your machine learning capabilities. Is a data warehouse in it. And you have the real-time intelligence, which you would have seen yesterday, a demo in Martin's presentation, and also in Kevin and Alicia's presentation yesterday. Very powerful capabilities there. You've got Power BI for being able to do your reporting and dashboard capability. And it supports mirroring of multiple database types, including SQL, Azure Cosmos DB, Databricks, Snowflake, and others. And all of it is underpinned by a data lakehouse, which is one lake. And that one lake has some really interesting features. First of all, it's organized by workspaces. So each developer or business unit can have their own workspace for which they can ingest data and then do their processing and all. But by the nature of the fact that it is a lake, it makes that data then accessible to everything, subject to whatever, I guess, access controls that you put on that data. It also has a really nifty feature called shortcuts. So shortcuts enables you to connect the data sources elsewhere without actually having to move that data. So it's a form of data virtualization. So if you look at this diagram at the bottom here, you can see that you can access data not only in Azure or on-prem or from your other Microsoft products like Dynamics with Dataverse, but also other clouds like Amazon and Google. So you don't have to actually move the data, but it makes it accessible through data virtualization, I believe. And on the compute side, it handles both Spark and T-SQL, KQL, which is Custo, and you saw that demonstrated yesterday in Martin's presentation for doing the real-time analytic stuff. And then and it also exposes your analysis services and dashboards like Power BI. Okay, so so this is, if you go to the Microsoft architecture space, sample architectures, you won't find specifically one that says Digital Integration Hub, but there is this architecture here which uses Microsoft Fabric as a basis, which does pretty much what a Digital Integration Hub does. And I'm just highlighting here the parts of that actually are covered by Fabric. And I think I have time to talk through this a little bit. So this example is about collecting telemetry data from vehicles when they're testing. And that data is ingested through the use of Event Grid. And it's sent to two different places. It's sent to function apps for doing some simple decoding of that data and reformatting of it to bring it into the real-time intelligence capability of Fabric. There's also other more batch data. It can be sent through Data Factory and processed in there through the use of the lakehouse, and then brought into the real-time intelligence. And the real-time intelligence, you see Event Stream and Event House in there, which is, again, what Martin went through in detail yesterday morning and how that's processed. And all that analysis that's done there can feed into your notebooks, if you want, or your KQL query sets that data engineers data scientists would use. You can expose it in visualization in dashboards or in Power BI. And also through Data Activator, you can respond and take action based on events, which again, Martin showed you yesterday an example of that. So you have conditional queries, and then you can perform actions on that. Like you might feed it, for example, into a Power Automate flow to take some action if the data quality degrades for any reason. So that's an example of how you would use a SaaS platform like Microsoft Fabric to kind of build Digital Integration Hub capabilities. So if you want to know how Microsoft Fabric would fit into this Digital Integration Hub architecture, it would probably look something like this. There's a few blurred lines here of what it does, but basically the entire high-performance data store and the analytics capability are already built into Microsoft Fabric. And for integration, for ETL type integration anyway, you have your Data Factory in there. There's some other integration happens as well, like with one lake you've got your shortcuts, right? So that has integration capabilities, and also real-time intelligence would have some as well. So choosing between PaaS and SaaS, okay, kind of depends on what your goals and what your capabilities are. Obviously, with the PaaS platform, you can customize, you can choose exactly what services you need for the functionality you need and customize it the way you want, but it's a lot of effort and a lot of management on top of that. With the SaaS, you get all that done for you. You don't have to worry about it, but you kind of need to kind of take the package as it is, right? So those are things there's a cost-benefit analysis that you need to do to decide which way to go. But you've got the flexibility, which is great. Okay, so getting close to wrapping up. So what I thought I would do now is just talk briefly through a couple of implementations that we've done at Deloitte that represent delivery of a digital integration hub type architecture. So the first one, I can reveal the client because Microsoft actually used this as a case study, and they published an article about what they did several years ago for New South Wales Health Pathology. So their goal was to establish a better integration platform, and one of they had a lot of different internal and external services and applications that they had to connect with. You can imagine pathology; it's connected to so much: hospitals, doctors, and everything else. One of their challenges too was that they had a lot of backend systems using HL7, but a lot of more modern systems that wanted to integrate wanted to talk with the newer and better protocol called FHIR. So there needed to be some translation of that. So when Microsoft published the article, they included this diagram, which kind of shows all the different Azure services that were involved in delivering that solution. You can see there was the Cosmos DB was used for the data layer, and then all the services listed on the side for being able to handle the integration and the API management and analysis. I wish I could give you the link to this, but it seems that sometime recently they took it down. So I could give you the link, but it wouldn't work. But that's what was published originally. What I will show you is our conceptual diagram of what we built for them. And one of the things I want to highlight in it is if you look at the data layer, which this middle section here, sorry for the other side, I can't reach my pointer on the other side. We did a canonical data model for them. So we kind of took the data from the backend systems and reorganized it and produced it in a way that made logical sense for the business, which gave them tremendous versatility in terms of how you could build the APIs and stuff that would consume it. And some of the benefits of that were not only were they now able to integrate with more modern systems by converting the HL7 to FHIR for consumption, but because of the effort that we've done in building an API-led approach and having that canonical data model, we made it far more easier for them to develop new applications. And one example of that was that within 2 weeks, they were able to create and deliver an SMS notification system for COVID. And if you want to read about that, there is a Microsoft article about that, and that's still there. And so you can go to that QR code. And it mentions in it that the reason they were able to do this is because of the groundwork we had done before in establishing that architecture, which made it very versatile and made it easier for them to expand. The other case study I was going to present to you is, I can't reveal the client name for this one, but it's a major energy supplier in Australia. And they basically wanted to modernize their entire platform with their integration and give not only better interoperability, but also better analysis and analytics capability and support. And for them, we implemented a digital services platform with using Microsoft iPaaS and Databricks. And we also included with them an analytics workbench and also data governance using Unity Catalog for that one. And this is an example of the architecture, the logical architecture for the integration capabilities. I'll delve a little bit deeper into the data side of things, but let me blow this up a little bit so you can see it. better. So as you can see, you have your systems of record at the bottom. You have, with Salesforce and SAP and Oracle database, and that feeds into the data layer, which we call a DSP landing zone, using Azure Data Factory pipelines. And then we have all the other consumers and other systems that contribute data interacting with that same landing zone by use of an Azure Service Bus. And we had subscribers built on web apps, functions, and logic apps, feeding and consolidating all of that data into the DSP landing zone, which we then use Databricks to do all the analysis on. So if I just go to the next slide, this kind of shows you what happens in the DSP layer. So you can see that we're feeding the data in using Azure Data Factory into the landing zone, and then we have the Databricks, and there's your medallion architecture again. So you can see we have the bronze, silver, and gold processing of all that data. And that data and that analytics can then be fed into either into dashboards like Databricks dashboard or Power BI, or you can create custom web apps for that. In this particular case, the client chose the middle option. They decided to use Power BI, but we built this so that they could do any one of those three things. So the benefits of all of that, not only did I get a very robust and solid and modern integration foundation for everything, but they now had an analytics workbench that they could use to gain all the insights in their data, and also a data governance tool set with Unity Catalog. And that enabled them to monitor things, to gain insights and intelligence, and comply with all the regulatory regulations that you have from government and the industry. So that's wrapping up here as a summary for that. Basically, a digital integration hub, its primary focus is about improving the performance of your APIs while protecting your backend systems from that traffic and that resource usage. And it also enhances your ability to support your analytical and your AI capabilities, because it gives you that consolidation and manipulation of the data and exposes it in a way that it can be consumed and feed that. And Microsoft gives you multiple options for how you want to build this. You can either build it with PaaS services and customize it the way you want, or you can have everything come in a box for you with Microsoft Fabric and have all that capability engineered for you, so you don't have to do it. You have different ways. I've got a slide with some references, and I will share these slides so that you can use it. There's a lot of links in here that I'm sure that you appreciate being able to access. And I do want to shout out this integration down under. So this was organized by Bill Chestnut in Australia. We decided we wanted to do a monthly webinar in an Australia or Asia Pacific friendly time slot. So we usually do this on a Thursday night each month, and the people who are involved, I think you'll probably recognize most of these folks. But Bill Chestnut is the person who organized it. We have people from the product team like Wagner, and we got other MVPs like Mick and Martin and myself as the panelists on this. And if you go to that page, not only will you find the details of the next webinar, but you'll find the recordings, the links to the recordings of every session that we do. And we have quite an extensive library. We've had some fantastic sessions by members of the product team, other MVPs, and just other integration community members that have given some great content in there. So, and if you want, I've got a handful, just a few stickers. If anybody wants an integration down under sticker, just see me after this. And that's basically it. So please reach out and connect if you want. As I said, if you want a link to me, just put in integrate in it so I know where you're coming from.